All right, so we're here with our PA class. We're going to be going over some questions from Unit 1, Part 3 for our AP review on summarizing distribution. So the first question is giving us a bunch of statistics, right? You have the 5-number summary here, which is the min, the max, your quartiles, and the median, as well as some other statistics. It has the mean, so the average. And do you guys remember what n is? Very good. In this case, it says your sample of 55 students, so that's why n is 55. Do you remember what lowercase s is? Well done, Alonzo, the standard deviation from the sample. Okay? So in this question, it says, which of the following is a true statement? If you look at all of the answer choices, it has to do with outliers. So I chose this one, and I put a bunch of space here so we could actually figure out and calculate, do all the work to see if we have any outliers, which you will have to do on the AP exam. All right? So do you guys remember the first step to beginning to find outliers? Interquartile range is the first step. Very good. So interquartile range, which is quartile 3 minus quartile 1. So in this case, that is 38 minus 25. What is that? 13. And then do you remember what number we used to multiply by with that IQR? Not 2. You might in your college class, but in our class we're using 1.5 times the IQR. So this is 1.5 times 13. All right. We are going to need our calculator later on. All right. So I'm doing 1.5 times 13. 19.5 is this number. Now, again, there's not really any way to describe this other than that it's 1.5 times the IQR. We use this number to find our fences. So the way I always do it is a lower fence and an upper fence. 19.5 is our number to use for the fences. To find the lower fence, you do quartile 1 minus 19.5. And the upper fence is quartile 3 plus 19.5. All right, so we have 25 minus 19.5. So our lower fence is 5.5. And our upper fence is 38 plus 19.5. 57.5. Okay, the way I try to describe this, right, is you can try to do it here. I always think when I'm looking out of my backyard, right, if a number is less than 5.5, right, well, I'll do it from here. It's like if I'm looking out my backyard, right, less than 5.5 is going to be what? Less than 5.5 is outside my fence in my neighbor's yard, so it's going to be an outlier. Something that's above 57.5 is going to be on the street next to me. All right, so that's an outlier. Okay, so let's look at our values here. What is our min? That's our lowest value. Is this below our lower fence? No. So since 10 is not below, do we have any values that are below 5.5? We do not. So do we have any outliers on the low side? No outliers on the low side. What is our maximum? 60. Is 60 past our upper fence? Yes. So this is where they're going to mess you up. How many outliers do we have on the high side? At least one, because could there be a value, Mia, that's 59? Yes. Could there be a value that's 58? Could there be multiple that are 60? Yes. So we can't actually say how many outliers we have. We know we have at least one on the high side. So if I go to my answer choices, so not A, no. So you see how C might be the one, Mia? You might choose C, which would be incorrect because 60 is an outlier, and then it says there can be no others, but we actually don't know. There could be others. 10 is not an outlier, so it's E. 60 is an outlier, and there could be others on the high end of the data set. Okay? Is everybody clear on how to find outliers? You will be asked to do that on the AP exam. Yes. 2 weeks from tomorrow. So that's the first one. Any questions? Say it again. You feel it? Oh. Number 2, and don't worry today, if we work quickly, we will get to second bars. All right, number 2. So 2, 3, and 4, this whole page is trying to match histograms with box plots. All right, it's trying to match them. I'm not sure how much of this you'll have to do on the AP exam, but it's good kind of practice to make sure you understand the difference in these graphical displays. Let's just first say, how would you describe the shape of this histogram? I would probably say unimodal first, but then skewed which way? To the left. So when you look at this, right, do you see any here that would be skewed to the left? And be careful, right, because if you look, these box plots are done vertically, right? It makes it a little trickier, all right? Where would you say the median is? The median would be? Yeah, I would think like because of the skewness, it's going to be a little further left, but I would definitely not put it in the middle, right? Probably still close to the right-hand side there, about 50. So the first one that jumps out at me is A. That jump out is here's the median, and then what do you notice about this long part of this box plot? What is that showing? That's the skewness, right? That long part of it, showing that tail. So this one is going to be A. Why not D? So D would be, if I had to sketch one for D, it would be more like this. Right? Where the median is further to the left and it's skewed to the right. Okay, good question. All right, you guys ready for the next one? Okay, so let's look at number 3. Now, can I look at 3 and 4 at the same time? Let's look at 3 and 4 at the same time. How would you describe 3 in terms of the shape? Symmetrical, yeah, unimodal and probably looks symmetrical. What do you think the middle is? Like the median is? About 30, all right? Now look at 4. You probably would still describe that as symmetrical, but not unimodal, potentially a couple of humps here. But what would be the middle? The middle's still going to be 30. So this can be tricky on figuring out which box plot it is, because the box plot is hard to show a lot of the shape. But here's what I would tell you, okay? Do you see how more of the data is in the middle? All right, so what is going to happen when I try to find quartiles? Where are my quartiles going to be? That's the medians of the upper and lower half of the data. Towards the middle, right? So I'm thinking, my quartiles, like maybe here's quartile 3, here's quartile 1, all right? But what about this one in number 4? More of the data is to the right or to the left, so where would my quartiles be for that one? Farther away, so maybe up here or down here. So essentially, when I look to determine these box plots, number 4 should have a wider box, right? So remember, because the box is showing you the middle of the box, it might not be in the middle, but the middle of the box is the median, and the edges of the box are the quartiles. So do you guys, I'm basically looking at B and C. We already ruled out D. Can you look at these two real quick? You see B and C, how they have the median are essentially the same at 30. But what do you notice about the length of these boxes? They're a lot different, right? The length of this box in box plot C is much wider or much longer. All right, so that's why I'm going to link up number 4 with C. So number 4 with C because of that longer interquartile range. And the more narrow or shorter interquartile range is going to go at number 3. I know that was a lot. How are we doing? Doing okay still? And I ruled out E just because I thought you guys would agree with me that the medians of these would both be 30. And if you look at E, the median for that one's more like 25. Yeah, doing okay? All right, we're going to go the other way. All right, so same process, but going the other way. Okay? Look at number 5. What do you notice is the median in number 5 for this box plot? 35. All right, so kind of when I look at it, and maybe a little skewness to the left. So I'm going to rule out D for this one because D is showing me more like skewness to the right, not to the left. I agree. I think it is C, Mia, because it looks like the median would be a little bit shifted to the right, but there is a little skewness to the left. So I agree. I pick C for number 5. Okay, what about 6? What's the median in 6? 25. So let's see. We obviously are ruling out C because we're not going to choose that one again. The median in A could be A, right? Because the median could be around there. And then B, I don't think it's B, right? That one looks like it's symmetrical, perfectly symmetrical. And then what about D? Could it be D? Yeah, it could be D. Could be D. And then I don't think it's going to be E because I think the median for E would be 30. Okay? So what do you guys think? So A or D, we're looking for number 6. So here's why I'm going to go with Mia, Alonso. The reason I'm going to choose D is because when I look at A, do you see how there are a lot more values here? So I think the width of the box, the quartiles are going to be closer to that 20, 25 number. And when I look at this, it looks like we've got the width going from 15 to 35. And I just don't see 15 and 35 being the quartiles. I think they'd be closer to 25. So I actually think it's going to be this one, all right? Because I think with this spread, it's going to allow the width of the box to be wider. But again, if you've narrowed it down, Alonso, between A and D, I'm okay with that. I am not concerned. That's right. Let's do 7. All right. Well, we're not doing, what did we already say? Not C, not D. We're not going to do A because we were kind of in between A and D in the last one. So really it's B or E. Why do you say E, Mia? But I think the median is 30 in B as well.
Because it looks like it's like in the middle.
Wait, hold on. Ethan? I agree, it'd be closer. I think with this one, right, the interquartile range is going to be a little bit wider, closer to that 20 to 40 range. So I agree. I think it'll be E as well. All right. How many more do we have? Okay. How are we feeling? Are we doing okay? What's our time right now? Do you think we can finish 8, 9, and 10?
Yeah.
You know what? Yeah, let's do 8 and 9 because 10 gets into something different. Let's do 8 and 9 and then I'll stop it. All right, here we go. 8. Suppose the average score on a national test is 500. So telling you the mean is 500 and the standard deviation is 100. And what are we doing to each score? Increase by 25. So if I had originally scored a 550, what's my new score? 575. All right, so this goes back to something we talked about in chapter 6, okay? If you take all of your data values and shift them by adding a number like a constant or subtracting a constant to them, all right, your measure of center, your mean, right, measures of center, will change, right? What's going to be my new mean? It's going to go up 25 points, right? 525. So it's not going to be these. It could be C, D, or E. Okay? But the measure of spread, right, if we take it, right, I always just think of, I'll do it like this, right? If I draw just imagine this is the box and whisker plot. You don't need to draw this. I'm just showing you this. So that's it. And I just move it to the right. And I know I'm sure it's not the same. But I try to just move that to the right. In theory, does this change the spread at all? No, it doesn't, right? The numbers have shifted to the right, but your highest minus your lowest mean is still going to be the same distance. All right, so what I'm trying to get you to understand for the AP exam is that measures of spread, like standard deviation, will not change if you just add or subtract a constant. So it actually is going to be C. It'll still be 100 for the standard deviation. Do you guys remember what you have to do to end up changing both? Multiply or divide. If you multiply or divide all of your data values by a constant, then you definitely will be changing the mean and the standard deviation. But if you're just adding or subtracting a constant, then only the measures of center, only the mean will change. All right, let's do number 9, and then I'll end the recording. All right, so number 9, when a set of data has possible outliers, so telling you that there are potentially some outliers going on, which of the following are preferred measures for center and spread? I tried to kind of go over this a little bit on Monday, all right? But this whole idea of like when you pick, the median and the IQR should be linked, right? They're together, and the mean and the standard deviation should be linked or together. When you see outliers or possible outliers, what are they going to have an effect on? You want me to draw a sketch? You said it right, Luis. I mean, like if I draw this, and then I put one out here, right? Do you see this bin out here? What's that going to do to the mean? It's going to pull the mean towards it, right? It's going to impact the mean. So should I be using the mean to describe this set of data? No, you can. It's just what would be a more appropriate measure of center to use? The median. And if you choose median, you should know what measure of spread should you be using with it. The IQR, the interquartile range. So median and IQR I would use for this scenario. What if they told you that the distribution was unimodal and roughly symmetric? Then what would I use? The mean and the standard deviation, right? So this goes all the way back to September, guys. If you see anything in your shape that's not unimodal and roughly symmetric, then you should be thinking median and IQR.